This is Dan Ogden, as Drew said, with the Idaho National Laboratory. I'm the Deputy Director of the Nuclear Science User Facilities, and I'll be providing the presentation today on NSUF. I'm going to talk kind of in three general areas. I'm going to provide a brief overview of NSUF, and then I'll talk about some of the specifics and changes in the CINR FOA related to NSUF, and I will also go over the NSUF-2 work scopes. So starting on our brief overview of NSUF, NSUF was established in 2007 as DOE Office of Nuclear Energy's first and only user facility. Our technical focus is in irradiation effects in nuclear fuels and materials. NSUF provides access to capabilities and expertise at no cost to the user. Included in that access is support for design, fabrication, experiment, transport, of course, irradiation, post-irradiation examination, and final disposition of materials are all included in the NSUF access. Our objective is to link the intellectual capital with the nuclear research infrastructure and expertise to fulfill the mission of DOE NE. Our projects are selected through an open competitive proposal process. We have two different ways to access NSUF. Of course, today we're talking about the CINR FOA, which is on an annual call. We have three different types of projects there: the large irradiation and PIE projects, which can range from 500K up to 4 million and last 7 years in duration. We also have PIE only projects, which typically range from maybe 50K up to 750K, 3 years in duration. We've also done some irradiation only projects, ranging from 500K up to 1.5 million. The other way to access NSUF is through our rapid turnaround experiment call. These occur 3 times per year. This is not part of the CINR FOA, and we won't mention that anymore in the conversation here. In general, proposals are welcome from universities, national laboratories, industry, and small businesses. There are, of course, eligibility restrictions within the FOA and also restrictions within the various work scope areas. Just a brief summary of NSUF. Most folks are probably aware that NSUF is a unique user facility. It is a consortium. In addition to the capabilities we have here at the Idaho National Laboratory, we have 20 domestic partners and 1 international affiliate. Between the INL and our partner facilities, bring a broad range of capabilities to address the NE mission. This slide just provides kind of a quick overview of which one of our partners have capabilities for neutron irradiations, ion irradiations, gamma irradiations. Most of our partners have some type of post-irradiation examination capability, beamline capability. And of course, we also offer high-performance computing through our capabilities here at the Idaho National Laboratory. Those are currently available on the Falcon supercomputer that's here. In the future, they'll be on our new Sawtooth capability that is going to be coming online here in the next couple of years. Wanted to mention a few of the tools that are provided by NSUF. We have a nuclear fuels and materials library. The library currently includes over 6,000 specimens. A lot of those have come from prior NSUF awards, but some have come from also from historical DOE projects that have left valuable material available at the national laboratories. Most of the materials are neutron irradiated. We do have a small number of ion irradiated materials. Detailed information is available through our website. You can get into the library and do a detailed search. There's materials in there: steels, other alloys, some ceramics, high purity elemental materials, some actinides. So a nice variety of materials there. It's a good place to look to see if we might have material of interest before you propose an irradiation project, as those take a lot of time and are expensive. We may already have something in the library that would satisfy your research needs. Also wanted to mention the Nuclear Energy Infrastructure Database. This is a searchable, interactable database that includes all of the pertinent infrastructure supported by or related to DOE, Office of Nuclear Energy. This has all of our partner facility capability as well as other capabilities beyond what is part of NSUF. Good information to support the infrastructure calls if you're going to put in for that. And it's also valuable to our users if you're looking for a particular research capability. Good place to search and see if it's available at one of our partner facilities or somewhere else. We do use the infrastructure information along with R&D needs to identify needs, redundancies, efficiencies, to best understand the utility of DOE&E's available infrastructure and to inform our annual gap analysis process. Okay, a little bit about the NSUF CINR history. So NSUF became part of the CINR FOA in 2015. The data here shows some excellent growth through the CINR. We started off kind of small in 2015 with 41 letters of intent, 31 pre-apps, resulting in 5 awards. Things have grown from there. 2017, 124 LOIs, resulting in 15 awards. FY 2018 was a little different year with the change in the schedule and with the reduced time frame. We saw somewhat of a reduction there, but we're expecting this year to be back on track with the normal timetable and see something similar to 2017 or perhaps higher as far as requests for NSUF access. Okay, I want to talk a little bit next about NSUF work scopes. You'll find our NSUF work scopes in both Appendix A and Appendix B of the FOA. So in Appendix A, the university-led, the NEAMS 2 work scope, separate effects irradiation testing for validation of microstructural models in Marmot. That is an NSUF work scope. And also Fuel Cycle 2.5, separate effects testing in treat using standard test capsules. So while those Appendix A work scopes don't start with NSUF, just want to highlight that those are NSUF work scopes. Appendix B, open to University, National Laboratory, and Industry. The NSUF 1.1 work scope, testing of advanced materials or advanced sensors for nuclear applications. And NSUF 1.2, irradiation testing of materials produced by innovative manufacturing techniques. There will be separate presentations on the university-led work scopes throughout the webinar, as well as the NSUF 1.1. In the NSUF 2 work scopes, which will be industry-led this year, NSUF 2.1, core and structural materials, NSUF 2.2, nuclear fuel behavior and advanced nuclear fuel development, and then NSUF 2.3, which is the advanced in-reactor instrumentation. And I'll talk a little bit more in detail about those NSUF 2 work scopes in just a few minutes. Let's touch a little bit on changes from prior year CINR FOA. So we have reinstated the letter of intent and pre-application for NSUF. Last year, those were combined into what we called an access request. Now, we're now back to 2 separate submissions there. Note that the letter of intent is mandatory for NSUF work scopes, as is, of course, the pre-application. Submittal of a preliminary statement of work and final statement of work are required in this year's FOA. Last year, in the shorter duration, we only had a submission of a final statement of work. This year we'll have both. Those will be submitted through the NEUP system, so it's a formal submittal. Note that the Illinois Institute of Technology MRCAT beamline at the Advanced Photon Source is not offered this year through the CINR FOA. We're currently resolving challenges there we're having in handling radioactive material. We are making progress with that, but we want to resolve that to all parties' satisfaction before we offer that capability again through the CINR FOA. The NSUF2 work scopes this year are only open to industry-led proposals. This is an opportunity and an encouragement for universities and national laboratories to support DOE's focus on helping U.S. industry. We have eliminated the NSUF 2.4 work scope. That work scope was originally tailored for the MRCAT beamline, but please note that we do have synchrotron radiation capabilities available at NSLS2 on the X-ray powder diffraction beamline, and that NSLS2 capability is available for any of the NSUF work scopes. We're also asking this year in the pre-application, full application, that our applicants declare the intentions related to proprietary data and let us know what the applicant wishes to protect during the irradiation or PIE phase. Examples of this could be chemical composition or physical properties. This information may be needed for us in order to evaluate the safety basis of the application. It may also be important for the scientific outcome. So just note that this information may negatively impact the feasibility of the project if we're not able to use that data in the manner we need to evaluate the proposal. Okay, a few reminders for NSUF. Uninvited full applications will not be reviewed for NSUF access. I've already mentioned high performance computing capability is available through NSUF. We really want to encourage a combination of both experimental and computational methods on these projects where that makes sense. We do ask for the source, scope, and duration of the R&D support for the NSUF access only work scopes, which are the NSUF2 work scopes. That's important. It's important for us to know that the applicant has funding to support their side of the project before we award the NSUF side. The NSUF access process is described in Appendix D. Feel free to venture back 100 or so pages into the FOA and read through that. Our non-negotiable user agreement is in Appendix E. I recommend you take a look at that as well and have your legal department take a look at that because you will be asked to comply with that through the proposal process. On our current schedule, letters of intent are due on August 30th. As I said, those are mandatory for NSUF access. Pre-applications will be due on September 20th. Preliminary statement of work will follow on November 15th, and the final statement of work will follow on February 12th. Okay, for the final part of my discussion today, I want to just touch on the NSUF2 work scopes. So these are the access-only work scopes as they're referred to. The objective here is to provide access to the capabilities of NSUF for research supporting the DOE Office of Nuclear Energy mission. The types of projects here, you can have an irradiation-only project, irradiation and PIE, PIE only, or a beamline project. So in general, this is open to all types of projects that NSUF does. The restrictions are as open to industry leads only. R&D support funding for the applicant is not provided. And as I mentioned, we do ask to understand that the applicant has that funding. NSUF does not fund travel, salaries, or other user costs. So typical Typical user facility model here, those responsibilities fall on the user. And it's important that the initial development effort should be complete and ready for irradiation. We do take a look at this in the process and make sure that the preliminary characterization and development work is complete and the project is ready for irradiation or PIE at NSUF. So that work needs to be complete before applying for NSUF access. Okay, the three work scope areas in NSUF 2. NSUF 2.1, core and structural materials. Focus here is understanding irradiation effects such as aging and material degradation. Fatigue, embrittlement, void swelling are examples of that. Also, development of radiation-resistant materials for current and future reactor applications. In the NSUF 2.2 work scope, nuclear fuel behavior and advanced nuclear fuel development. Focus here is to increase fundamental understanding of the behavior of nuclear fuel, to improve performance of current fuels or develop advanced fuels, understand irradiation and or thermal effects on microstructure, thermophysical, thermomechanical properties, chemical interactions. Projects should aim at proposing simple irradiation experiments with PIE examination, investigation of fundamental fuel performance aspects such as radiation damage, species diffusion, or fission products. We're not looking for people to propose an entire fuel development campaign under NSUF 2.2. And as I mentioned earlier, coupling of experimental methods with modeling and simulation is encouraged. Actually, it's highly encouraged. And our final work scope here is NSUF 2.3, advanced in-reactor instrumentation. Focus here is to support qualification of advanced in-reactor instrumentation with specifically focused on characterization of materials under irradiation in test reactors or for online condition monitoring of power reactors. Advanced instrumentation, sensors, and measurement techniques for use in advanced reactors is encouraged. In the NSUF2 work scope area, the contacts are Federal Program Manager Tonsel Seleckler, and then our NSUF Director here at the Idaho National Laboratory, Rory Kennedy. That concludes my overview of NSUF. We'll open it for questions. No questions yet, Drew?
Oh, sorry, I was muted.
Oh, the silence was disturbing me for a moment.
No, that's okay. So if anybody does have questions, please use your GoToWebinar application to write a question into us, and we will relay those to Dan. Dan, first question. Can I assume that ion irradiations as opposed to neutron irradiations still count as irradiations?
Yes. Irradiations can be a gamma irradiation, ion irradiation, or neutron irradiation. All are irradiation.
I need to do neutron CT on heat exchangers. Can NSUF accept handling that type of a project for irradiation?
So it sounds like this would be an NRAD type characterization of a heat exchanger component. I guess at first blush, I would say that probably does not fall into our technical focus of irradiation effects on fuels and materials. If the person asking the question would like to contact us, we could discuss that further.
Is a list of the available facilities on slide 4 online?
Yes, if you're interested in our capabilities, please visit the NSUF website. And feel free to contact the technical leads identified there for further discussion of the detailed capability, availability, and technical details.
Is it possible to get access to your library of irradiated samples of structural alloys before submitting a proposal in order to obtain preliminary alloy design data?
We may already have some of that information, so what I would suggest doing is look in the library. If there's a material of interest, please contact us. We may already have some of that information regarding the characterization of the pre-irradiated material, and may be able to answer your question without having to supply access to the material. If we don't, we can discuss options there. There may be a way for us to get that if we don't have it.
Are the two synchrotron irradiation beam lines having difficulty handling radioactive materials?
As I mentioned earlier, we are having some challenges handling radioactive materials at the Advanced Photon Source at the MRCAT. We have been making progress there, but we haven't resolved it to everyone's satisfaction. Obviously, those facilities are a little bit different than a hot cell facility at the lab, so there can be some challenges there dealing with not only levels but potential contamination. So each proposal related to that will have to work through those challenges carefully to make sure we understand what they might be and make sure it's acceptable to the facility.
Is there a connection or possibly separation between the scopes proposed in NSUF 2 proposals and GAIN or industry FOA proposals?
I'm not an expert on all the work scopes in the GAIN and industry proposals. I suspect there's potentially some overlap there, but if someone in Germantown would like to answer that or help me with that, I would appreciate it.
That's a question we'll take as follow-up.
Okay.
We don't have the industry FOA folks in the room here to answer that question, so we will defer that and answer that by email to the proposer.
Very good.
If I have already neutron irradiated materials in storage in my hot cells, I assume I can submit proposals using these materials, ones that are not part of the NSUF library?
Yes, that's true. You can submit using those. We always encourage those type of opportunities to be considered as things to go into the library first. We do view that favorably in the process.
We'll continue taking questions for the next few minutes. If you do have any questions or follow-up questions, please submit them so we can get them over to Dan. Dan, does the library contain results of prior examinations?
We do have connected to the library all of the information that we have available on the material, which would include information on pedigree, pre-irradiation characterization, as well as the radiation history of the material and connections to other, some of the results of the prior projects. So we're trying to connect as much information as possible to those specimens in the library.
Okay, Dan, it looks like that's all of the questions that we have. We will take a 5-minute break and we will be back to visit on the infrastructure FOA. Jonathan Kirkham from the NSUF staff will be giving that presentation. So please join us again in 5 minutes. Thanks, Dan.